Hello everyone, welcome to my YouTube channel Captain Chandan. So today the next chapter is radio wave propagation. Radio propagation is nothing but the way radio wave transmitted from one point to another point inside the earth atmosphere or in the space. So we will learn factor affecting propagation of electromagnetic wave, or you can say radio wave. Attenuation, the loss of signal strength in radio wave as it travel outward from transmitter, or simple reduction of signal strength during transmission. You can see in the image the magnitude of signal getting weaker, that is attenuation. Radio wave attenuation is primarily caused by the absorption of radio signal by some atmospheric phenomena like rain, shower, ice, cloud, dust, etc. Absorption. As the radio wave travel outward from a transmitter to energy is absorbed and scattered by the molecule of air and water vapor, dust particle, water droplets, vegetation, the surface of earth and the ionosphere. In the diagram, when a wave transmitted, it is in thick arrow, means signal strength is good, but when it passes by obstacle like water, dust, the energy of signal lost due to absorption by obstacle. The effect of absorption expect ionospheric increase as frequency increase, and it is very significant factor above 1000 megahertz. So kindly remember this point. If you increase the frequency, the absorption will increase. Frequency increase, absorption increase. Remember this term. Sometime it is asked by Dgca in CPL or Atpl examination. So remember this one. If frequency increase, absorption increase. If frequency decrease, absorption decrease. Inverse square law. The electromagnetic radiation from an aerial spread out as the surface of a sphere, so the power available decrease with increased distance from transmitter. The intensity of radiation is inversely proportional to a square of the distance. So let's understand this thing. In the diagram, S represents the wave source or transmitting point, and R represents the measured point or distance. At R distance, in one square box there is 9 wave. You can count the red spot. Now further at a distance 2r, there will be 4 square box and the 9 wave divided 3 and 4 dot in the box. Further at third distance, further at 3r distance, the total box is 9 and each box have 1 wave. Gradually you can see when electromagnetic wave travel, the power of wave decrease. You can see in the picture. So you can say power is inversely proportional to the distance, meaning to double the effective range of transmitter, then the power would have to increase by 4 times. This term is very important for Dgca, CPL and Atpl exam. Remember these things. For example, at R in the diagram, one house have 9 security guard, but at 2r distance in one house only 2 or 3 security guard. So to make more powerful house at 2r distance, each box should have 9 security guard, so that it can match the same power like at r distance with 9 security guard. It means at 2r distance the power must increase by factor 4. Hope you will understand this concept. It's very easy. Just analyze the diagram. The effect of static interference is greater at low frequency, and at VHF and above the effect of interference is almost zero. Static interference is nothing. In older AM radio or older television, there is always noise sound. It is because of interference. During the rainy season, you can ask your older, if they used to play radio, there will be some interference sound. So that all because of interference. Power. An increase in power output of a transmitter will increase the range within the limit of the inverse square law. As we know, To double the range of radio transmitter would require the power to be increased by factor. We already discussed that one, so kindly remember these things. There are three principal paths that radio wave may follow between the transmitter and the receiver. Surface wave. It follows the contour of the Earth's surface. Surface wave propagation exists at frequency from above 20 kHz to about 50 MHz from the upper end of VLF, means very low frequency, to the lower end of VHF, very high frequency. The portion of the wave in contact with the surface of Earth is retarded, causing the wave to be bent around the surface of the Earth, a process known diffraction. As the frequency increases, surface attenuation increase, we discussed already, and the surface wave range decrease. So if frequency increase, attenuation increase, so the result will be radio wave cannot travel more distance, because due to attenuation it loses the power. The losses to attenuation by the surface of Earth are greater over land than sea. So for surface wave, land range is lesser than sea range. We can see further. A horizontally polarized wave will be attenuated very quickly and give a very short range. Therefore, vertical polarized is generally used at the lower frequency. The usable range achievable over sea and land for a medium frequency transmission at a frequency of 300 kHz is given by sea range is 3 times power, land range is 2 times power. Very important terms. So for surface wave, land range is lesser than sea range. A space wave. The space wave is made of two paths. The first is direct wave and the second is a reflected wave, a ground reflected wave. It is a line of sight. A combination of surface and a space wave is called ground wave. So remember this thing, a space wave equals direct wave plus ground reflected wave, and ground wave is a surface wave plus a space wave, or you can say ground wave is a surface wave plus direct wave plus ground reflected wave. To get maximum ground wave range, use the frequency for maximum diffraction and least attenuation and use vertical polarize. The portion of wave which first passes over the sea accelerate and the wave bend away from the normal, that is toward the coast. This is known coastal refraction. When passing from lower denser medium to higher denser medium, they bend toward the normal and vice versa. They always bend toward the denser medium. Remember both terms. This is a very important formula. Sometimes it may ask in Dgca examination. A line of sight range VHF can be calculated using this formula. Range will be in nautical mile, 1.23 times root under transmitter height in feet plus root under receiver height in feet. So this is called a VHF formula. Sometimes it can be asked in Dgca examination, so you have to solve. Is a very easy and short numerical. So for example, what is the maximum range? A receiver at 1600 feet can receive a VHF transmission from a transmitter at 1020 feet. So very simple, just apply of VHF formula. So if you put all the value, the range will be 88.6 nautical mile. Very simple. Ionospheric propagation. The ionosphere extends upward from altitude from above 60 km to limit to the atmosphere, normally 1500 km. The lower layer occur at average altitude of 75 km and are known as D region, or you can say D layer. Form at sunrise and disappear at sunset. Very important. So D layer disappear in the night time. Remember this term. at an average altitude of 125 km is present throughout the 24-hour and is known as E layer. The E layer reduces in altitude at sunrise and increase in altitude after sunset. The final layer of significance is the F layer. At an average altitude of 225 km, the F layer is split into two at sunrise and rejoin at sunset. You can see the layer diagram. So remember, in night time D layer is disappear. Electron density is maximum in F layer and least in D layer. Sky wave. The propagation of radio wave reflected or refracted back toward the earth from ionosphere. Sky wave are electromagnetic wave transmitting antenna emit and then receive after being reflected by ionosphere. In diagram, after transmitting, it return back from ionosphere then goes to the receiver. This is the diagram of a sky wave. Here we will discuss some terms. First, angle of incident. The angle which a radio wave form which normal at transmitter is called angle of incident. Critical angle. The angle of incident at which the first sky wave is received on the earth is called critical angle. Signal lesser than critical angle does not return. Skip distance. The distance between transmitter and point of surface where the first sky wave return, that is called skip distance. Dead space. The area between the line of surface wave and the point of reception of first sky wave, that is called dead space. Multi-hope refraction. Returning signal is so strong it will be reflected back to the ionosphere again from the earth. This may be several times. That is called multi-hope propagation or multi-hope refraction. Fading. Two signals from same transmitter arrive at same receiver following different path may be out of phase causing fading. The best example for fading is mobile phone. Sometimes the voice is not clear on phone while talking is because of fading. Because two signals came at the same time. So let's discuss some important terms. At a given frequency, as ionization increases, the refractive index, hence the amount of refraction affecting the radio wave will also increase. This means that refraction will take place at a smaller critical angle and the skip distance and the dead space will decrease. Conversely, a decrease in ionization will result in an increase in critical angle, skip distance and dead space. All the term is very important. So, what is ionization in atmosphere? The production of ion in the atmosphere by the loss of electron from a molecule called ionization, and this happened because of solar radiation. This is not so important but good to know. Frequency increase, the critical angle will increase and the skip distance and dead space will also increase. As the frequency increase, the surface wave range will decrease. So there is an increase in dead space caused by both the increase in skip distance and decrease in surface wave range. Conversely, a decrease in frequency will give a decrease in critical angle, skip distance and dead space. Height of layer. The skip distance will also be affected by altitude of the reflecting layer. As the altitude of the layer increase, then the skip distance will also increase and greater range will be experienced by refraction at the F layer than the E layer. Lower frequency and medium frequency sky wave propagation. During the day, the D layer observed radio energy at a frequency below about 2 megahertz. 2 megahertz is lower frequency and medium frequency. At night time, D layer disappear. So at these frequencies, a sky wave refracted at the E layer because E layer is present. This means the sky wave at LF and MF are not reliable for continued long range uses. Due to this, skip distance increase and a receiver become into dead space. VLF, LF are observed by layer. VHF and HF pass the layer, so the part of MF and HF return back to the earth. Note, the maximum range for a sky wave will be achieved when the path of the radio wave is tangentially at the surface of the earth at both transmitter and receiver. This is very important. HF frequency reduce the half during night time to prevent receiver come into dead space. So remember, in day frequency increase and in night decrease the frequency. Rule of thumb is said that the frequency required at night is roughly half that required by day. Multi-hope propagation. A sky wave occurs when the wave is refracted at the ionosphere, then the sky wave is reflected back from the surface of the earth to the ionosphere again. Multi-hope sky wave can achieve a range of half the diameter of the earth. So multi-hope can increase the range. Duct propagation or super refraction. The condition which rise to super refraction are decrease in relative humidity with height, temperature falling more slowly with height than standard, fine weather and high pressure system, warm air following over a cooler surface. So this is a condition for super refraction. So let's summarize the topic. Surface wave which reaches receiver by traveling along the surface of the earth and bend around the surface of the earth. Direct wave. VHF band and higher frequency, the wave reaching a receiver in a straight line of sight are called direct wave. Reflected wave. Wave reflected by the object. Space wave. Direct wave plus ground reflected wave. Ground wave, a space wave plus surface wave. Depend on frequency. Lower frequency, higher diffraction in surface wave. Higher frequency, greater attenuation in surface wave. Vertical polarized wave have a minimum attenuation in surface wave. That's why NDB or VOR are vertically polarized. In ionosphere, more density, more attenuation. In ionosphere, lower frequency, greater the attenuation. More attenuation on land, minimum at on sea in surface wave. So this is the end of chapter, and see you on next chapter. Thank you for watching. Kindly do like, subscribe my channel, and share those who want to become a pilot.